Welcome back. In the previous videos, we gradually built up our terrain using multiple layers of erosion: hydraulic erosion, thermal erosion, and wind erosion. After that, we applied a smoothing pass to refine the final surface. At this point, the terrain looks great, but there's still one problem. Take a look at the edges of the terrain. Because all of the erosion simulations operate across the entire height map, the borders can end up with sharp, artificial cutoffs. The terrain starts to look as if it has been clipped by a rectangular box, which is not something you'd normally see in a natural landscape. Today, we're going to fix that. We'll use the Heightmap Edge Fade Node to gradually fade the terrain toward the edges, creating a much softer and more organic transition. The result will feel less like a bounded height map and more like a natural landmass emerging from the landscape. I right-click in the graph and type Fade into the search box. Heightmap Edge Fade appears as the only result. I select it. This node will be placed at the very end of our pipeline between the Heightmap Smooth node and the Heightmap to Terrain node. Let's connect it. The Heightmap output of the Heightmap Smooth node goes into the Heightmap Edge Fade node, and the output of the Heightmap Edge Fade node is connected to the Heightmap to Terrain node. Now let's take a look at the settings. There are only two parameters here, simple but very effective. First, we have fade width. This determines how far inward from the edge of the terrain the fade effect will be applied. The default value is 12. Since our terrain is 2048 by 2048 units, a width of 12 units is actually a very narrow border region. You'll see exactly how noticeable that is in a moment. Next, we have target height. This defines the elevation that the terrain fades toward at the edges. By default, it's set to 0, meaning the borders gradually descend all the way to ground level. Let's click Generate and take a look at the initial result. Take a look at the terrain. The edges are no longer sharp. We now have a smooth transition around the borders. However, with fade width set to 12, the effect is still limited to a very narrow band right at the edge of the terrain. For a more dramatic and natural result, I'll increase fade width to 130. This affects a much wider border region of the terrain, creating a broad foothill-like transition around the mountain. And the difference is remarkable. The terrain now gradually descends in every direction. From a distance, it looks much more like a natural mountain mass rising out of the surrounding landscape. The mountain blends smoothly into lower elevations through this broad foothill-like transition, and the hard artificial terrain boundaries are gone. The result feels significantly more natural and believable. With that, our erosion series is complete. Over the course of these 5 videos, we've built a complete terrain generation pipeline from the ground up. Purlin and ridged noise create the base landforms. Hydraulic erosion carves channels and valleys. Thermal erosion stabilizes slopes and softens harsh transitions. Wind erosion introduces directional character and asymmetry. Heightmap Smooth cleans up surface noise. And Heightmap Edge Fade removes artificial borders, creating a natural-looking landmass. Together, these nodes transform a simple procedural height map into a terrain that feels far more realistic and geologically believable. In the next video, we'll finally move beyond terrain shape and start working on terrain texturing. Using the Splatmap Preset node, we'll automatically paint the landscape based on elevation, slope, and curvature. Snow-covered peaks, rocky cliffs, grassy hillsides, and valley floors will all be assigned automatically. With a single click of Generate, we'll create a complete terrain material distribution across the entire landscape. See you in the next video.